Okay, internet, let's be nice. All right. So the beginning here is just sketching these things. And then I think people ask me about this, but you determine the output based upon the number in the parentheses as x, and then that determines which one you pick. So what do you do to the x? Well, which one of these domain regions is the x in, and then you apply that to the particular expression that they tell you for the range. And the same thing for these. Now, in this case, on 27, they're endpoints. So it's not taking the domain for all values in the real number system, whereas over here, because the arrows point forever to the left and right, where's my cursor? Oh, there it is. And so when you're less than 0, that means forever to negative infinity. And when you're greater than 0, it means forever to positive infinity. Whereas here for 27, you had specific endpoints. So you stopped at -1, you stopped at 3. And so that's the only real difference. Okay, and then for this one, this was the one that had the word continuous. And, I'm not quite sure if you guys, are familiar with sketching these graphs a little bit, but just did the homework because I want to make sure, even if it's only one issue. So notice what I did here. The boundary line's at 0, and there was only one valid value at that, and that was 1. So that top circle was shaded. And then when it's not 0, that means both left and right, you got a slope of 2. And since it's 2x, there's no y-intercept, so it's anchored at the origin. So this at the origin is not shaded. It may not look that way because I got to zoom it up, but that should not be shaded at the origin. Okay, and then 31, I did a silly mistake here. I just drew it and didn't think, oh wait, that's a negative slope. So that's why I changed it here. Now in this case, they both happen to anchor at the same output when x is 1. So even though you're not getting the output when x is 1 from the left graph or the top expression, since when you replace the x with 1 in both of these, they wind up being the same. So that's why it looks that way. You're not going to be able to draw an open circle on top of a shaded circle, so they just anchor at the same place. Okay, and notice how I'm stating the range, right? In this case, from the graph, you can see that for each value on the y-axis, there's a place on the graph starting at 1. And then over here, since the line starts at 0 and goes forever up, starts at 0 and goes forever down, that means there's a number paired on the y-axis. Now, I made a mistake. I just caught it. Except 0. So I should have put except 0 here. I just caught that. And again, it's probably because looking at it, I didn't see an open circle, knowing me. Now, both of these are continuous because there's no invalid value issue, right? And I'm just going to assume you know what x and y intercepts are. Okay? And so then for this one, the same thing. Notice you got the 3 different regions. And so we got the left side, which is a +1 of slope, crosses the y-axis at 3. And then we got the valid value when x is 1. So that's why I shaded that circle on the top of the vertical dashed boundary line. And then once you go to the right, you start having your negative x plus 2 graph. So it's going to have a -1 slope going down. Now I anchored it here at 1 by putting 1 in for x. -1 plus 2 is 1. Okay, and then I anchored the left side of this at 1 by putting 1 in for x. Okay, so in this case, there is valid value for each part of the domain because there's no invalid value at the boundary line. Everything else checks out. So that's why I wrote this statement. But if you notice here, there's a gap between 5 and 4. Okay, and so once you go to the right side, the anchor starts at the same y of 1 that was the endpoint on the left. And so you are able to cover everything from 4 down to negative infinity. But there's nothing in between 5 and 4. And so that's why I wrote it this way. And again, it's not valid at 4. There's no anchor there that's shaded. So that's why I wrote it that way. Okay, and again, this is still continuous because in each value of the domain, in each value of the stated domain, there is a valid result in the range. There's no issue at this boundary line. There is a valid value when x is 0, it's 5. Okay, then we get to 35, and this is where we start having invalid value issues. Because if you look at these, the boundary line is 1, but it never gives you a way to get the range when x was 1. And so there's an anchor for the left graph with the slope of 1 going through the y-axis of 1. And there's an anchor for the right graph, which is just an x squared. But when x is 1, there's no valid value. So we say this is not continuous because there's an invalid value at 1. Okay? And again, you can see the stated range. Since there's an overlap between 2 and 1, then each value of the y will be paired on either branch of the graph. Okay, so push that button and hope for the best, I guess. All right, and then again, here we have another discontinuity, break in the graph with no valid value for similar reasons. So we got our absolute value on the left and our cubic on the right. And so I'm just sketching this. That's all it's asking you to do, right? And so since there is no definition of what the range is when x is 0, the anchors for the left and right branch at 0 have no valid value, right? And so it's not continuous when for the domain value of 0. So in this stated domain region, okay, it's not continuous for the value of 0. Now people might want to put a little comma here and say x can't be 0, or you can just state that it's not continuous there. So there's kind of an overlap in those two ideas. Okay, and so here's our friend, the step function. Now you didn't get to do the number 41, where it had a 2x in the middle. We're going to look at that today. So this hopefully wasn't too bad. You're just doubling, right? So instead of going 0, 1, 2, 3, you're going 0, 2, 4, 6. Okay, and so then remember with this one, it's within each interval of whole numbers, the greatest integer less than or equal to basically means shift down to the left. So between 0 and 1, including 0, you're always going to get 0. Between 2 and 1, including 1, you're going to get 1, but then you multiply by 2. Okay, and then once you get to 2, you jump to the next interval. So between 3 and 2, including 2, you shift down to 2, but then you double it, so then you get 4. And so you get this step pattern. Now, in this case, there's valid values in the range for each value of the domain, because when you start at the step and go to the right, once you get to the open circle, you jump up and you're on the next step. So jump discontinuity, not because of an invalid value that results in the range, okay? And so for every real number in the domain, you're going to have a associated y value. However, not every y value shows up on this function. Notice you're skipping by 2's. Nothing in between 0 and 2. Nothing in between 2 and 4. Nothing in between 4 and 6. So how you could represent 0, 2, 4, 6, 8, 10, 0, negative 2, negative 4, negative 6, negative 8, 10. You could just say that down here and then just put dot, dot, dot. But here's a more mathematical way of doing that. Okay? Basically, we're getting 2 times all the integers. 2 times 0, 2 times 1, 2 times 2, 2 times negative 1, 2 times negative 2. So that's why I wrote this. Remember our friend, the little z, the funny z? So here's the range. The range you get by multiplying 2 to all the integers. That'll produce all these numbers. That's a more mathematical way of saying that. And again, this is continuous because each value in the domain is associated with a valid value in the range. Whereas over here for 37, in the stated domain, right, there is a value in the stated domain of 0 that does not associate with a value in the range. Okay, so it's not continuous when x is 0. All right, and I don't know if you guys needed help with this. These were linear, so you can just find the slope by just using a little step. But anyway, there's the solutions. Does that assist or help at all? Does anybody have any things you want me to address or re-explain? Okay. So again, I will give you guys the solution. So I'll do the homework too. Occasionally I've done it in the past, but this one I did this morning.